Let's look at the part 2 of the matrix. So under the part 2, you want to look at determinants of a 2 by 2 matrices. So the determinant of a matrix is a single value that we calculate from the matrix. And this value summarizes important properties of the matrix. For example, that single value can tell us whether the matrix can have inverse or not. So, when the determinant of the matrix is 0, what it tells us that the matrix is collapsed and cannot be undone. What it means is that we cannot determine its inverse. Then when it's greater than 0, that's if it's positive, we say it works normally and preserve its orientation. And then when it's less than 0, we say that the matrix flips its orientation. So in this lesson, we will look at how to calculate the determinants of a 2 by 2 matrix. So let's look at the general rule. Anytime you have a matrix, when you draw a line from the top corner, the top left corner, to the right hand down corner, this line we call it the main diagonal or the major diagonal. Then from the left down corner to the top right hand corner at the top here, that line is called a minor diagonal. So for 2 by 2 matrix, we use the product of these two lines to calculate for the 2 by 2 matrix, the 2 by 2 determinants of a matrix. So for the 2 by 2, we are going to have, in this case, we are going to have what? The product of the leading diagonal. So which we have what? A times D, which will give us AD. Then we will subtract the product of what? The minor diagonal, which is C times B, which will give us BC. So we will find the difference of it. So when we will find the difference, the result that we will get, that's what we call what? The determinant of the matrix. So let's use our general rule here. Let's use our general rule here to calculate for the determinants of these three matrices. So let's go. So from our matrix, from our first question, we are going to find the determinants of this matrix. So in this case, we are going to find the product of the leading diagonal, so which is 21 and 9. So you have 21 times 9 minus then the product of the minor diagonal, which is 4 and 17. So you're going to have a 17 times 4. 21 times 9 will give us 189 minus 17 times 4 will give us 68. Then we find their difference. This will give us 121. So it means the determinant of this matrix is 121. Very simple like that. Again, let's look at the determinant for the question B. So the same procedure. We are going to have the product of the leading diagonal. So you have 2 times 6 minus the product of the minor diagonal. So negative 3 times negative 8. 2 times 6 will give us 12 minus the product of negative 8 and negative 3. That will be 24. So finding the difference, we are going to have a minus 12. So it means that the determinant of this matrix is minus 12. Let's find the determinant of this matrix too in algebraic form. So the same procedure, the product of the leading diagonal. So you have 7 times a plus 3 minus a times 7, a times 7 minus a. So let's multiply 7a plus 21, then minus 7a plus a squared. This and this are like terms, they'll subtract each other. So we have 21 plus a squared. So this will be the matrix, this will be the determinants of the matrix. So this will be the determinants of the matrix. This will be again, we can have equation involving matrix. So in the questions over here, we are to solve the following equations. The sign that you are seeing here, the bar that you are seeing, are the symbol for determinants. So in each of these questions, what the question is saying that the determinants of the matrix equal to the value given. So when we take question A, it says the determinants of the matrix S plus 1 and 2. That's the first row being x plus 1 and 2. And then 2x minus 1 and 3. Its determinant is 4. So we are to determine the value of x. Likewise, this question, the bar that you are seeing indicate the determinants of the matrix. So the determinants of this 2 by 2 matrix, the determinant is 0. You are to find the value of x. When you come here to the same thing, take note that this symbol, the bar symbol that you are seeing, this bar, when you see a matrix with a bar like this, it means that's the determinant. So the determinant of this matrix is 1. We are to find x. The determinant of this matrix is 2. The determinant of this matrix is 2. Is 2. And we are to find the value of x. So we will do 2, and then you also do the other 2. So let's go. So we have the determinants to be 4, and we are to find the value of x. So the same procedure, you multiply the product of the leading diagonal. So you have 3 brackets open x plus 1 minus the product of the minor diagonal. So in this case, we have 2 times 2x minus 1 equal to 4. So we have 3x, then 3 times 1, 3, minus 2 times 2x, minus 4x, minus 2 times minus 1 plus 2 equal to 4. Let's group our like terms. So we have 3x minus 4x, 3 plus 2 give us plus 5 equal to 4. This will give us minus x plus 5 equal to 4. We subtract 5 from both sides. So we are going to have a minus 5 here, so that this will go 0, and then we have only minus x here. So you subtract 5 from both sides. So we do the same thing here. So 5, positive 5 plus minus 5, that will give us 0. So you're going to have what? Negative x equal to minus 1. Then we divide both sides by negative x equal to 1. So in that matrix, our x is 1. So if we are to find that particular matrix, then we are going to have that matrix to be our x, which is 1, plus 1, so 2. Then this 2 side will also be 2. This side we have 2 times 1 minus 1, which is 1. So if you want to prove it, you can prove it to see whether yes, you are going to get the determinant to be 4. So let's see. 2 times 3 will give us 6 minus 1 times 2, which will give us 2 equal to 4. So question B. The determinant of the matrix is 0. We are to find x. So you multiply your leading diagonal or the major diagonal. So you are going to have 3 times 5x plus 2 minus 4 times the minor diagonal, which says x minus 3. So 3 times 5x, 15x. 3 times 2 plus 6 minus 4 times 6x. That's minus 24x. Minus 4 times negative 3 plus 12 equal to 0. So let's do our simplification. 15x minus 24x, 6 plus 12 give us 18 equal to 0. 15x minus 24x minus 9x plus 18 equal to 0. We subtract 18 from both sides, so we have minus 18 and minus 18. So this will lead us to minus 9x equal to minus 18. We divide both sides by minus 8. Minus 9, our result, x will be 2. You can prove it to see whether it's true. So you will do C and D and put your answer in the comment section.